Good word.
Hello.
Edward. Hello.
Hey, hi.
How are you?
Good to see you.
Yeah, we've good. It's Ed. Nice to meet you. I'm not sure how many others might join. There's
Okay.
just sort of a general interest around the project. The project itself is well, okay. So there's a CNCF project called Service Mesh Performance.
Okay.
So it is, more or less dedicated to that very specific topic. The concept and the sort of the original issue that was filed was some long time back, prior to Packet being acquired, prior to Packet being the provider, I think, of the infrastructure in the first place. I don't know.
Okay, so it goes back a ways. Yeah.
And we finally got. And so actually, before I go further in, I'll say anyone else is welcome to join the call. And I think we've got maybe one other person on. And so for the other person that's on, do you want to say hi and just introduce yourself? Yep. Yes, you. I don't read Sanskrit. I assume that's not Sanskrit. What is that? Arabic?
Looks like Arabic.
How are you? Hopefully you can hear us. If your audio doesn't work or you're not in a position to use audio, maybe just open up the chat and just say a quick hi. Oh, I realize my name's a little off as well. I'm signed into a different account. All right, there he is, Tausif. Welcome. Hey, Tausif. How are you? We're just about to kick off the call, kind of getting folks introduced. Nice. And Nishant is with us as well. And Nishant. Hey, Tausif.
Yeah, Haley.
Gentlemen. Hey, Nishant, you want to just say hi to Ed and the rest of the folks, just to introduce yourself real quick?
Yeah, sure. So, hi everyone. I'm Nishant, and I'm currently in computer science undergrad, based out in India. And yeah, I haven't really contributed to Layer 5 yet, but yeah, I'm very excited about it, and I want to do it. And currently, I'm learning on the basics of Kubernetes, service meshes, and all.
Nice. Beautiful. This is a great place to jump in. There's some DevOps to be learned. There's a little bit of, well, if I can abuse the heck out of that term, I get out of, pardon my
whatever
French.
you're doing, it's definitely DevOps.
Yeah. And so Nishant, thanks for jumping on. And Tausif is here. Tausif, if you can say hi real quick. Otherwise, drop a note in the chat.
Hi, Lee. Positive side. I have completed my master's in as an MCA last year. I'm also getting training in DevOps from edX. So I just want to explore this pool of opportunities over there and want to learn more about service meshes and all.
It's awesome. It's very good of you guys to be on. That's great. There's all of us are learning.
Just see if I think there's an echo. Okay, now it's gone. Yeah.
Sorry, I didn't get you.
Oh, thanks and welcome. And I'm getting an echo from your connection, so I'm not sure
Cool. All right. Cool. Guys, let's jump in.
Okay.
So is this the right page? This is the wrong page. See if I can find that. So there's Ed, there's a couple of projects that are interrelated in this effort. One of the the core project is service mesh performance. That project and the CNCF's Technical Advisory Group for Network, or TAG Network, is home base for, well, any of the networking related open source projects that the CNCF has. It could be networking, it can be some other projects, but so there's a number of service meshes that the CNCF has and this performance project. And it's just been an outstanding question in our sector of the industry. Like, hey, how do we compare and contrast the performance of these things? What's the overhead? What's all this? And we've been building and building and building tooling to help empower people to answer that question for themselves. Because you'll find info out there, some of it's biased and some of it's like, well, that's interesting, but that's not my environment. And so we've got a variety of configurations we want to run through. We've built up a lot of tooling that helps us automate the stand up of these meshes, the deployment of the apps, the generation of the load and all that stuff. And so, yeah, our hope is that within a pristine environment that we can go through and run a myriad of tests. And so some of the questions that no doubt you'll have, as you're digesting this, you're saying, well, okay, great. So did you need a server or did you need 500? And too bad if you needed 500, what was the size and what was the, I'll make it super easy. And I hope that this makes it easy and say, like, almost all of the tests are, almost all of the configurations are valid. It's sort of whatever's the most representative of people running clusters in general. A lot of people who care about the performance are going to be running, a number of clusters and quite a few nodes per cluster. And but we can extrapolate out some of the test results. The initial, like if someone has 40 clusters with 40 nodes a piece, like that's not what we're asking for. That's too much for us to try to. Initially, a couple of years ago, it was like, hey, if we had about a 20 node cluster, that'd be nice. 10 would work. 5 would work. 3 will, it starts to get lesser representative. I think if we, 100, sure, but I wouldn't, I think we'll waste your time. I think, hey, maybe in 2 months from now, we'll come back saying, yeah, we really got our act together. The scripts are, we know what we're doing now in Equinix as well. And so here's the crux of part of today's conference, or what I'm hoping we can revolve around. So it's a lot of the automation that we have that will deploy these service meshes, that will deploy the sample apps, that will generate the load, that will then measure it, and all that automation. Conveniently for some of these service mesh projects today, that's bundled into a GitHub action. We run the GitHub action and we hammer the heck out of whatever VMs GitHub is giving us in their hosted system. And I'm ignorant, but I'm ignorant of the specifics, but I'm aware that you can also connect up self-hosted runners. So you can take that same automation, but then connect it up to, and have you done that in the past, or is that are you familiar?
Yeah, I'm familiar with it. We've had a number of folks, either for CI purposes or for other sort of testing purposes, set up self-hosted runners in our infrastructure. So as I understand, I don't have a ton of firsthand experience with it, but from reading the docs and talking to folks about it, you basically stand up a machine and on that machine deploy some agents, long-running software that that taps into the GitHub action queue. And as jobs come up, it takes those jobs, ingests them in, and runs them. And so the biggest benefit that we've seen, you can do self-hosted runners on architectures that GitHub doesn't have, like ARM. You can run them on more powerful machines than the GitHub systems have, or just have more flexibility in general as how to do things. But yeah, the self-hosted runner, I think, would be a perfectly reasonable way of doing this with the runner, running on the Equinix system.
That's a relief.
Yeah, I mean, I don't think it's, there's a little bit of a setup step, but I don't think it's any harder than running it in any other environment. We have bare metal servers rather than VMs. And so you'll perhaps be in a situation where you have to either restore things to an original state or tear down infrastructure when you're done, rather than just spinning up a brand new fresh VM to do it. That's probably the biggest difference between a bare metal environment and a VM environment. The software is all going to run the same, and network interfaces might have different names, what have you. But getting back to a known reliable state may require more setup code, more teardown code than you're used to.
Can you speak a little bit to the bare metal provisioning with Kubernetes systems, or if
Yeah, so we've got some existing configurations using Terraform to do network provisioning. As it turns out, in the Kubernetes space, everyone deploying a commercial Kubernetes does things a slightly different way. And we've done a bunch of work to try to deliver components that are reusable in that sense. But basically, deploying a new node is a matter like, you can imagine an architecture where your GitHub runner, right, the runner code that's self-hosted, does the deployment script out of that runner, sets up a bunch of brand new nodes, launches off those tests, tears them down when it's done, and then the runner, stays active, but the Kubernetes infrastructure is essentially ephemeral.
Yeah, okay. Okay. What's the fast? So there's a lot of things about performing these tests that we just don't have a strong opinion on today. So like what distro of Kubernetes? We don't care. What distro of Linux? We don't care. Or rather, those are things that people will tell us probably after we go out and hopefully not piss everyone off, but after we go out and share some test results, people will get pretty interested, and they'll come back and say, well, that's because you weren't running the right kernel, or you weren't, didn't do that. And
Sure.
these things. And so,
Yeah, so we've had pretty good, so one of the test constraints is going to be setup time. Like you don't want to spend any more time than you have to spinning up the cluster. You want to spend that time usefully running tests. So we've done a bunch of work to reduce the startup time for a couple of specific operating systems. We have quick install Ubuntu nodes, if that's a reasonable choice for you. We had been doing quick install for CentOS. CentOS is a little bit funny right now because of the CentOS 8 end of life from Red Hat. But we've got some alternatives there. And if you're in a CentOS/RHEL world, happy to understand, what would work out there. But the basic notion is that the bare metal machine spin up time, we sort of pre-provision things a little bit so that you're not spinning up from cold start, you're doing a warm start. And I think typical startup times are measured in the small numbers of minutes. So like 3, 4, 5 minutes from pressing the button to having a running system. Doing the whole Kubernetes install, depending on that might take a little bit more time, but we're not talking about hours or days to get a cluster spun up. It's completely automatable and sort of small numbers of minutes for time for things. I don't know how long your tests typically take to run.
yeah,
Are we?
Yeah, that's another area where it's like, where we just haven't gotten enough feedback to hone in. Like an hour a test is probably is a good starting point to figure out if that's, and then go off and get feedback from folks.
Sure. And is the nature of the test coverage like you're doing performance tests? Excuse me. You're doing performance tests, so it's like lots of different kinds of tests over the span of an hour. One, like logically, one very long test that goes through things. Do you need to test within the data center, across data centers? Across data centers on the same continent, across data centers across an ocean. Like there's a lot of things that could be tested.
Yeah.
Right? So, and there's probably some like smallest reasonable set of things that's interesting that's likely to work, and then extend out from there as you get more.
I do anticipate, unless we hear differently from the CNCF staff, I anticipate this is probably the start to a long relationship, or rather that like, that to your point, I think what you're essentially saying is, hey, we can start relatively simple, gain some traction with respect to interest from like eventually we want to be able to empower others with the same tooling to the extent that they have an extremely specific thing about, cross-region failover and then such and such, the other, that they could participate in publishing in the same format such that it's relatively vendor neutral, relative, it's as unbiased as you can try to get. So for us to kick off, the simpler the stand up of the provisioning of a nominal sized Kubernetes node, running of what's probably like, it's like that hour-long test is really probably more fairly static. Like we might stepwise up the load, but at least to start, potentially not just leaving it running that long to account for any I don't know, what would you say? I don't know.
Just to let it stabilize, right? To
Yeah.
make sure that you can actually demonstrate sustained load, and you don't like have weird memory leaks or unreliable this or unreliable that, right?
Yeah.
So in terms of we don't have as much variety in node size as, say, an Amazon configuration, which can get everything from a fractional CPU up to very large. But we do have a couple different node sizes, basically small, medium, large, occasionally extra large. We've got some node types that have 4 NICs on them. Most of them are dual NIC configurations. And there's a little bit of variability in terms of network speeds, anywhere from 2 by 10 gigabit to 2 by 25. We have some experience from the network service mesh team who really helped us design that quad NIC node based on expected telco use cases. And that's a server that's like an N2 dot large, I think it's what it's called, N2 dot, it's an N2 server. We have a next generation N3 server in the works, but not yet shipped. It's probably a first quarter or early second quarter thing. So in terms of like how performance intersects with networks and NICs and CPUs and memory, like there's a little bit of, there's some variety there that's worth acknowledging. You don't have to pick up, it's like there's no perfect thing, but there's going to be some things that are going to perform better than others.
Yeah, or there's a few, that's great. I was talking to one of the NSM maintainers a little earlier today and a part about this. There's a couple of people from Intel that are involved in this initiative, and they will be quite opinionated about the CPU, and for my part, you can see the data that the original issue was opened. For my part, I just want to run a dang test and publish.
I understand. Yeah. And like we do, I mean, people who are opinionated will find things to be opinionated about, both CPUs and NIC types. We have both Intel and AMD CPUs. We have both Intel and Mellanox NICs. And there may not be a perfect machine, right, to satisfy everyone's needs or what have you, but we've published all those specs, and as you look through them, you can find systems that would be, appropriate. And then what I'd imagine is, just in terms of machine allocations, the runner setup should let you have essentially one or a very small number of permanent systems that are basically hosting the runner piece of things. And then I would think that since you're only doing tests for an hour, 2 hours, 3 hours at a time, that most of this usage would be ephemeral, in the sense that you'd provision some machines, spin them up, load all the software, run all the tests, report back the results, tear them all down, return them to the pool. And we have just generally a lot more capacity for short-term ad hoc spin it up and tear it down. I mean, that's a lot easier for me to talk to people about than if you said, oh, we need 1,600 machines for 6 months. It's like, well, no. But potentially it's like even larger tests, if they're set up in such a way that they're torn down relatively quickly, might be an excellent way for us to, soak test new hardware, get some opinions on, you might be the first person to boot it. So there might be hardware problems. Like a good hour's test might show that, whatever. So just, try and understand it's like capacity for supporting this probably will be improved by some attention to detail in the automation stuff.
Yeah, that's perfect. I mean, that just further incentivizes, having the spin up and tear down about as long lived as the tests themselves. There isn't. I mean, like, yeah, we would figure out later if someone really, if there was some telemetry that we didn't collect that needed to be included in the report, that like because of the that someone needed to go back and look over, but that would only be after analysis and discovery later. Oh, we just figured out we weren't even collecting enough potentially.
Yeah, and I would also think that if you needed a test cluster for your test clusters, right? You needed some sort of small but representative, relatively permanent setup to do debugging or development or whatever on. That's completely in scope as well. So
that might help. I mean, while we fumble around, I'm assuming fumble around over the self-hosted runner and getting the quick install Ubuntu, as we fumble through it for the first time, we may not want to allocate many nodes at all, or
just enough to prove out the system.
Yeah,
prove that you can do it and that you can scale it and tear it down as well. So. Yeah.
Some of the to your point, like where the complexity, the combinatorial math comes in about the myriad setups and configurations. I mean, like there's a lot just within the hardware that we were talking about, but then there's a ginormous number within the way that the various software settings and the way that you're telling them to run. And some of us involved are quite intrigued by at the various ends of that, on the hardware end or on the software end. And so,
right. It's also worth noting in terms of like getting a very specific configuration. It's harder to do ad hoc, but if you need to, again, have a small number of nodes that you wanted to make a lot of potential changes to, spin up time would be a little bit longer, but if you wanted to boot a custom kernel, a completely custom operating system, we do support booting over iPXE. So, as you extend in that software direction, like we need to have exactly this, then that's one piece of things. For dedicated nodes, we can also do specific BIOS related or firmware related things. I don't want to promise that ad hoc that you can specify that, because when you get a machine from the pool, you get what you get. But it's possible that the sort of work that you're doing, will depend on the latest NIC drivers or the latest kernel patches or any of that stuff. And I think it's quite reasonable to expect that the nature of the bare metal system you have gives you, as long as you understand as long as we understand what you need, would give you some flexibility there as well.
In terms of so this is very helpful. Say a bit more, if you would, about the general tooling by which sort of access is controlled or access is. Is there a portal involved? Are there VPNs involved? Are there folks who credential? Is there there's probably a whole list. There's a whole set of documentation probably that you guys have about in part, this conversation is to help answer tons of questions, but also
Sure.
Eventually kind of scheduling of, like, if we were to start out with like 4 nodes for some time while we fumbled through the trying to, like, using a control node to provision a 3-node cluster and then running through that automation and kind of that scheduling. Is that, and if that's just like the quick, if it's the Ubuntu quick 2-node, like it's sort of your commonly available node type that.
Mm-hmm. So, yeah, so let me talk through the sort of what you get when you spin up a new server. They're all bare metal machines, so there's no joint tenancy. You have the whole system to yourself. When the system is booted, it has all of the automation that you'd expect from a Ubuntu system, including things like Cloud Init, so that you can load things at boot time. We often have people doing deployments with Terraform or Ansible or sort of common deployment tools. One interesting thing is when a system comes up, so we have a console. At the console level, there's organizations, which would be the CNCF organization for this, and then individual projects under that. One or more people can have access to a project. When they create their account within that project, they'll upload their SSH keys to our portal, and then at provisioning time, we inject those keys into the system so that when the machine comes up, the authorized users and only the authorized users can SSH in to the system. So there's some, you can of course do more after the system is up, but there's a fairly straightforward get the system online with the set of people who should have access to it. In addition to access over the standard network interface, we have a serial over SSH interface, which essentially taps into the console port on these things. It's not a hardware port, it's delivered over IPMI. But it lets you do things like get access to a server after the network configuration has gone horribly bad, right? Because there's a separate management network that you're connecting through. You can also remotely reboot the machine, reload it with a new operating system, do other sorts of management tools from our console. In addition, there's a full API that gives you access to all of these same attributes, and we've got a CLI tool that wraps them as well. So, the combination of all of that lets you get a machine up and running using common tooling. But if something goes wrong, you have a authenticated point of access to get to a console.
Nice. Okay, good. Yeah. So it sort of invalidates when I was saying like a 3-node cluster and I had said 4 nodes to do that. It's like, well, yeah, except you don't really need the 4th node for that because the management console is there as your bastion point, as your point of control for the litany of things that you just said.
Right.
Yeah, all sounds really good.
I mean, it seems, to me, it sounds, it sounds perfectly reasonable, right? You're just loading some software in a machine and running some tests. How hard could that be? The setup automation, we've seen that pattern before. Often like coming out of something like Jenkins or some sort of CI infrastructure where people will spin up a machine or a set of machines and tear them down. The thing to watch for while you're doing this is that not all automation technology is completely perfect. And sometimes people will spin up machines and for whatever reason, a logic error or a bug or whatever, the system fails to tear down and you start to accumulate multiples of what you thought you were going to be using. One method that we have to deal with that on an automated level is an option at provisioning time that is basically a time to live or a timeout option for systems. If you know that your machine shouldn't ever run for more than a day, you can set it to expire tomorrow and we will turn it off for you. And so that in a test environment is a useful additional backstop for things.
That's great. That makes a lot of sense. Yeah, it's instead of container or VM sprawl, sort of bare metal.
Yeah.
Sprawl, if you will.
Yeah. The other thing to know is that if you end up in a situation where you have to run a lot of tests in a certain data center, when a machine deprovisions, when you destroy it and it gets turned off, doesn't really get turned off, it goes through a deprovisioning cycle where we scrub it and get it ready for the next person. That deprovisioning cycle takes some time. Depending on the size of the machine, it can take longer to deprovision it than it can to provision it. And we've had other people doing CI and test environment cycles where they cycle through a lot of machines really quickly and end up essentially using up a data center as the systems deprovision, wait a while, and become ready again. So it's worth acknowledging that if you have, dozens of 10-minute tests, that it would be better to reuse a machine than it would be to, like cycle it through with a reinstall rather than pick a new system from the pool.
Temporarily consuming all available nodes. Oh, yeah. Yeah. Nice.
That's just like, that's an artifact of how like things actually take time. And they may take time invisibly to you, but
Yeah, that makes it's somewhat, it's someone's server somewhere. Like you're, it's you know. So this is, Edward, we're like, we've tried for a while to be, and we've written like doc after doc of here's the things we want to test and this kind of a situation, this environment, this thing. And for my part, I'm either just kind of burned on it or have just acknowledged like we really just need to start. And then like, I expect it that I don't know, I guess in the best of ways, I hope that there are enough people that are involved and so intrigued by what's going on and people learning so much that something like this is something that we need to be very much paying attention to. Like, I hope that we get that far, I guess is what I'm saying.
Yeah. Well, there's a lot to be said for what you learn during the process of getting an automated test environment set up. You know, people who've done the sort of, not sort of performance tests, but like CI/CD cycles, appreciate that within an hour or less, they can get a handle on whether the change that they've made makes a difference, has unexpected results, whatnot. You know, the processes of just getting it so you can get automated test results. I don't want to minimize how hard that work is, but it's valuable once it's done.
Yeah, that speaks in part to why that issue is so old. Like, because it's an acknowledgement that like we should not start until we think we've got it all under a single, click, and then we'll enter into Equinix's world and work through hopefully a smaller set of automations to then get it to the. Yeah, it really is part of the thing that just for your own, as we go to start this relationship or what have you.
Yeah.
This, for context, I suppose, the particular project or this specific one is, so it's service mesh performance. Like people have all kinds of, so there's a specification by which we provide a common way to kind of capture and articulate the performance of your cloud native workloads that are running on a mesh, and then consequently sort of running on Kubernetes, and then consequently on whatever's underneath, and to help espouse best. There's a lot of different technologies. Maybe WebAssembly could be various things that are running around, and you can figure it in various ways. And so one of the objectives, actually, this is like an overview deck. Not that we won't go through it, but the part of the goal here is to engage in this lab on, I have no idea what cadence, but on some sort of a cadence to publish, to like sort of track and part of the goal here, the reason for a lot of the tooling and investment into the tooling isn't just it's for what we just said, but it's also to say for each of the service mesh projects that get measured, they may well know better than we do that there's a certain tweak in the config that really makes a difference, and they may want to be in control of the reporting of these. So part of our goal is to hand off let others come in with that tooling and sort of self-report. So it might be, so part of the works that we engage in here with respect to self-hosted runners might be that others are using the same tooling on runners that they have, not necessarily, maybe some of them come in and want to parlay and participate in the same discussion.
But basically to enable them to repeat the results in a comparable fashion with their own configuration.
Yeah, exactly. Yeah, because they're, in concept, they're the ones that are the most, right. We don't want to we want them to make themselves look good or look bad. Let them do that.
Right. Because I would think that there's probably some tension between everyone wants to work together towards a common goal and everyone wants theirs to be the best. And that sort of usual tension, right? That's
Yeah, part of our goal, part of my specific goal is to help them, is to provide a vendor neutral venue in which each of them can highlight their strengths. It'll be more about highlighting strengths than it is about, you know, and yeah, and so 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 there's a couple of other folks that there's a couple on the phone who are interested in being involved, and there's a collection of folks that are maintainers of this project and kind of dedicated to seeing through the publication of those reports. Can't remember, there was some other reason I was trying to give you additional context. We want to publish the results on a continual basis. Yeah.
Yeah, from a benchmarking perspective, what we're generally speaking fine with having benchmark results on our infrastructure published, as you don't have to get special permission or agree to various things, and we're not protective about that. The hardest thing to do, probably the hardest part of this that I can see is if you end up with any dependencies on like very specific kernel versions, very specific driver versions, like understanding that some elements of network performance are at the high level of this, what the software is doing, but since you're on a bare metal environment, like it may go down to something lower. Yeah, so this is the server list. Like,
yeah,
for prototyping something that should run everything we need to do, we have a small version and a medium version in Intel and AMD flavors. The N2 system has quad NICs. If you scroll down a little bit more in the grayed out ones, the N3 large, I think, is going to be an interesting machine. Because I think that has a quad NIC as well.
Very good. I'll suggest this, that hey, we want to be, like I said, hopefully this isn't the first or last or time that we're speaking, but and so yeah, let us be as good of let us be good citizens to the extent that we can, and like actually I'll say this, like initially like I think boy, there's a lot.
I just interrupted something because I realized before. So when you're trying to offer the context to Edward, maybe you wanted to show like what you intend to measure on the performance, like system to system or service mesh to service mesh. Because I think the system to system, it's it seems to me it's compatible with the style that Equinox have the ramp up of the lab. Just
yeah,
when you are presenting the performance result. Yes.
Yeah, we're generally, one of the things we're really heavily focused on is that, so we'd spin up a Kubernetes cluster, put some nodes in there, deploy a service mesh on the cluster, deploy a sample application, grab at least one, maybe multiple, over time it would be multiple load generators. You sometimes run them at the same endpoint, like the same microservice, sometimes at separate microservices. track how much load we're generating over a certain time, measure the latency by which responses are coming back, measure the throughput by which responses could be sent and received. And all the while trying to collect sort of some standard node level statistics about CPU memory, some fairly common stuff there. Like, yeah, to the extent that so there's various levels at which to take those measurements. So if within Equinix, either through the API or if there's sort of or an easy path to some of that hardware level telemetry, or find maybe it's just like, hey, what you commonly find is people just in the Kubernetes land here, just deploying like a Prometheus node exporter or something. And
Right.
there's examples of that, like, you know, like like I have zero opinion on like almost everything to start with, because it kind of just doesn't matter. There are others involved that will come in with particular goals in mind about my goals are much more about a static, stable, consistent. My goals are much more about like constraining the hardware and having it be static and not, and then really evaluating the various configurations that we can do.
Okay.
Different service mesh types, different configurations of those meshes, different. We'll inject some faults at a software level and watch as the microservices respond or don't respond. Like for some of the other folks involved from Intel or others, they're going to your point, potentially going to be a lot more concerned with node profile types and drivers and OSs and
Right.
And so.
Yeah, we have had other people do. I'm trying to remember the name of the project, but they were doing performance evaluation. What I remember from it was, so we try as hard as we can to have all nodes of the same type be as identical to each other as possible. The reality of the world, even before the supply chain issues came up, but sort of the reality of the chip world is that there can be differences between two identical machines that have the same SKU. We saw this with like, I don't know, it was like the stepping on a CPU, or like something so minor that no one should notice. But we had someone with very precise measurement tools who was able to tell us that we had two machines that were the same, that were different. So, you know, as you look to getting results that are repeatable, getting results that you can run over and over again and get the same answers or within tolerances of answers. The network architecture that we have is such that there is a top of rack server that data goes through. It should be the case that traffic from other machines or machine pairs shouldn't impact your performance. But you know, it's at some level it's hardware. So
for single data center configs, is that okay? I guess I'm answering my own question. It looks like that. Just like see the docs here for a description of that top of the layout.
yeah, so should you notice or not? And are there API? We had talked about, I don't know if this is the case right now. We had talked about API features that would let you specify either rack diversity or lack of rack diversity, right? Do you, like for some applications, people want all their machines to be in the same rack for performance. For other applications, people want all of their machines to be in different racks for diversity and fault tolerance. So I think at the level that you're measuring, there might be some small amounts of variance depending on exactly which systems you get, right? Even within the data center, because there's going to be a few more meters of fiber between the two. I don't know if your measurements are going to be sensitive enough to notice a few hundred nanoseconds or a millisecond or a couple of milliseconds here or there, but just know that there's some, like, there may be some variance there.
And to your point, like, having a control, what do you call it? A control group, and a control node or a control test or something to increase, at least speak to the confidence of the and that's in part why we might run some things for an hour, or like some of the soak tests might be, or the different types of tests that we would run
might run longer.
You're right that all things that I hope that we really care about later, or some of the folks that are participating, they have the world's best and finest instrumentation for hardware level measure, like, and they're not on this call. So we'll see if they try to bring some of those to bear, or like some of those that represent the hardware vendors themselves that we're AMD and Intel that we're speaking of, like they have, they may, Anyway,
and we have good relationships with both AMD and Intel, and have done early access programs with those folks, and have gotten at some of their sort of newest hardware. So if at whatever point of the cycle you're doing this, that you find a need to get deep into the weeds for stuff, we may be able to provide some resources as well.
For like this cross-plane integration, do you know folks at Equinix that were involved in this partnership or this kind of relationship? Or
so I'm in the developer relations group at Equinix Metal, and one of my colleagues was lead on this development. So
nice. Yeah, very good. Part of the reason I ask is it goes back to what I was saying earlier about the work that's gone into the tooling. So we kind of focus that conversation on a GitHub action. Okay, fine. The tooling that's inside the action, it actually uses some of the same tech that Crossplane does. That tooling is a CNCF project, Meshery. And so Meshery, you could refer to it in various ways, but an orchestrator of the 10 plus service meshes. And so it has load generator inside, it has kind of instrumentation inside. It has actually to date, it keeps track of, people, the various, so the part of the project, the goal of the project has been to empower people to run these tests themselves and report them. And then for us to share with the world what, hopefully be able to inform people, if you're running it like this, do that. If you're running it like, we want to try to espouse best practices. And so the reason I note that is well, I mean, reading into the future, it's possible. It's possible that it would, speaking of empowering others to run these tests, or empowering the other projects to run these tests, there might be enough interest that Meshery makes its way here.
Yeah.
And so,
Yeah, we've been, I mean, this set of integrations is work that we've been actively doing and supporting. Each of the projects evolves at a certain pace, some faster than others, some easier to work with than others, right? But we're really committed to providing that cloud environment on top of bare metal. So whatever experience you have in doing stuff,
yeah,
we're interested in that and in helping it forward.
nice. Well, Edward, very nice to meet you. I think,
Yeah.
I think you will lead the way with respect to where to get started. You were alluding to kind of where to get started in the how to. Some of the info you'll probably share is about how to go about. Like I get like either requesting a couple of nodes or identifying when those are just freely available and grab a couple, or when to where the inflection points are in terms of pre-planned activities.
Yeah, so the CNCF infrastructure itself is managed by the CNCF. So Ihor has been lead on actually doing account setup and like who needs to have access, make sure they get information. So I would, if you know what you, to the extent that you know what you need, he can help very straightforwardly get access set up. For my guess is that this is probably a 2-part or a 3-part ask. The first part being just like, hey, let's get some infrastructure up so that we can test the tooling. And then probably it's like once the tooling is proved out, then there's the sort of bigger ask that says, well, we know that it works. We want to test it at a larger scale. What kind of machines do we need? Where do we want to put them? How long do we want to run them for? Like the sort of like second stage of the experiment, right? Once things are working. But based on all I know and our budgets and access and whatnot, asking for, I don't know, something on the order of 4 machines, 5 machines, something like that. All in one data center. Some reasonable type that you could prove things out on, that you'd hold them for a long time. We have more inventory in some data centers than others, so it's probably worth the conversation before turning them on to make sure that I don't come back to you 3 weeks later saying, hey, those machines that you had, we need them for a customer. But yeah, I'm happy to run point on that.
Nice. Edward, I think that takes care of, actually, honestly, Edward, I think I probably got a 2-year-old account from Ihor, or like, I think they were, when Dan Kahn was here, he was pretty quick to try to get us in, and a lot of time has passed. But so this is great. I mean, this is Edward, very nice to meet you. We'll make a mess of things, I'm sure.
Yeah, and we're always really interested in seeing people who are doing state-of-the-art stuff do it on our platform, right? That's a perpetual interest. So, I'm very interested to see what you can prove that works, and also just to understand your results.
Fair enough. Adina, anything else for today? I hesitate to ask.
I'm mute. I'm not mute now. Okay. No. I really enjoyed the presentation. So thank you very much for having Edward and for allowing me to be in this meeting. Yeah, I had no clue that Equinox has so many. Let's say so many types of provisioning, and for me it was really cool. It was really cool, the presentation. So thank you very much.
Last question, Ed.
Sure.
Tinkerbell.
Yes.
Is Tinkerbell? Am I getting the right mental association with Tinkerbell and Packet and Equinix and? Okay.
Yeah. So Tinkerbell is a provisioning tool based on our production core stuff, but it's open source. It handles the low-level Pixie boot and the power off to initial operating system load.
Nice.
And there's a whole stack of stuff associated with that, including a language for doing fast boot of systems that we've been working really hard at to, how quickly can you get a system from scratch to run.
Yeah.
So,
okay. Yep. Good. Yeah. There's a startup here I'm in Austin, Texas. So there's a RackN.
Familiar with those folks, yeah. Some of the same space, RackN. Red Hat has been working on a project called Metal Cubed or Metal 3 that sort of fits in the same space. To a certain degree, Canonical's Juju kind of fits in that same space. A lot of people have rolled their own sort of things. We really wanted to open source some of the work that we had done, because I think some of the control plane for that is novel, and there's some more cloud native elements of the whole thing that are new to this space. It's interesting talking to the very small number of people in the world who understand how servers boot, and how old some of that infrastructure is. Like, I don't want to say rickety because that would make it sound maybe worse than it is, but like there's a bunch of code that runs, for the first couple minutes of every server, and most people in the world don't see that code. And so most people in the world don't care as long as their server comes up. And
yeah,
by nature of what we do, we care about that a lot.
Well, I guess actually one other question, and that is, I'd participated in creating Redfish, kind of Redfish V1. And is that of the IPMI that we were speaking about earlier, just out of curiosity, is that, do you know, is Redfish, did it become a popular thing, or is like do you know those IPMI interfaces adhere to?
Yeah, Redfish, I think is a thing. I don't live in that world as much as some other people, but I've heard it come up. We have part of our engineering team doing a bunch of work with the BMC, including a project called OpenBMC, which is basically trying to let the end user of trying to let someone like us control that system. So like within OpenSea, I think it has a Redfish interface as well as other things, but you're working with really resource constrained essentially embedded systems. And that's finding people. Yeah, finding people who even know that stuff exists, let alone have opinions about it. You find some very smart people at that layer of the stack.
Yeah. You can't just plop in your own REST API package that brings in 9,000 other dependencies and then expect that it's going to fit or compile into the.
Yeah.
So, well, very good. Ed, thanks so much for the time.
Yeah, thank you. And reach out to me with whatever way is best with any questions. Happy to set up a call if that helps. If you have questions that come up along the way in terms of integration, happy to bring in some of the people who wrote the code on our side to guide you along the way. But this sounds like something that overlaps with things that have been done before, so I don't anticipate any brand new problems. Just
nice, yeah,
the usual.
Just tired and old problems.
Just the things we may have already run into before. So
nice, yeah. I'll go about introducing a couple of other folks probably via email, and we'll jump on Ehor's back and see if we can generate some load. So
that'd be great. Generate some load, time some packets, see how fast they go. Scratch your head why they can't go faster.
Thank you.
Thank you, Ed.
Thank you very much.
Okay, thank you, Dina. Thanks, Tassim.
All right.
Ciao, ciao.
Bye all.